Lesson 3 Logarithm. Hello everyone, my name is Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important lessons from me. Logarithm. What is logarithm? It is another way of writing indices. Now we can compare index form and logarithm form. In index form, we have a to the power m equals b. We can write this equation into logarithm form, which will become log a b equals m, where a is the base, the m is the index, and the b is the body. Let's look at a few examples. 2 to the power of 3 equals 8. When we write it in logarithm form, it becomes log base 2 8 equals 3. Next, 3 to the power of 4 equals 81. So, in logarithm form, it becomes log 3 81 equals 4. Now, how can we interpret this equation? Log 5 125 equals what number? So we can take it like 5 to the power of a number equals 125. What is this number? So it is 5 to the power of 3 equals 125. Therefore, log 5 125 equals 3. Common logarithm, we can write it as log base 10a or log a or just log lg a. Natural logarithm is log base ea or just ln a, where e is natural number. Here are the 6 laws of logarithm that you need to memorize. These laws are derived from laws of indices. If you can understand them, you actually don't have to memorize. Let's look at these laws one by one. Law number 1, log base a b times c equals log base ab plus log base ac. This law is called product law. If you look at this law, the two numbers in the body multiplied together, they can be split out and becomes plus. Law number 2, log base a b over c equals log base ab minus log base ac. This law is called quotient law. The two numbers inside the body, b divided by c, can be split, becomes minus. Law number 3, log base a b to the power of c equals c log a b. This law is called power law, where you can see that the power for b, which is c, can be brought down to the front and become a constant, c log ab. Law number 4, log a c equals log b c over log ba. So we use this law to change the base. For example, if I want to change the base a to base b, I can apply this formula. Law number 5, log base a equals to 1. This law can be applied when the base and the body are equal. Log base a 1 equals to 0. This applies when body equals 1. Law number 6. If log base ab equals m, hence a to the power of m equals b. This law is called anti-log law. Usually it is used when we solve equation and we want to find the value of b. Let's look at one example related to simplifying logarithmic expressions. Here is the example. simplify and express as a single logarithm log 2 115 plus log 2 125 minus 3. Just look at this expression. This expression contains 3 terms. The first 2 terms contains log and the third term has a constant. So the requirement for this example is to express it as a single logarithm. Here is the solution. First, we see there are 2 logs plus together, then we can apply law number 1, which becomes log 2 115 times 125 minus 3, and it will be log 2 25 over 3 minus 3. So now we have 2 terms, one is log, one is constant. So we can apply law number 5 so that the constant 3 multiply with log 2. Then we can apply law number 3, where the constant 3 will become the power of 2, which is log 2 to the power of 3. And at this stage, we can see that the expression now contains 2 log with a minus in between. Therefore, we can apply law number 2, and it will becomes log 2 25 over 3 divided by 2 cubed, which is log 2 25 over 3 times 2 to the power of 3, and the answer is log 2 25 over 24. Now, let's try one similar example yourself. Simplify and express each of the following as a single logarithm. A. Log x over 25 plus 3 log 2x minus log 4 over 125x. B. 1 over 2 ln 9e square minus 2 ln e over 3 plus ln e over 18. C. Log x 16 plus log x sub 32 plus log x sub 2. You can pause the video and try to do it yourself. Here is the solution. For A, we can see that there are 3 terms here and 3 of the terms contains the log. For the second term, there is a constant 3 multiplied with log 2x. Hence, we can apply the power law and it becomes log 2x cubed. For the first term and the third term, we just copy down. Then we can see that they contains plus and minus. We can apply law number 1 and law number 2, which the plus becomes multiply, the minus becomes division. Hence, it becomes log sub x over 25 times 2x cubed divided by 4 over 125x. Then we can simplify this expression. It will be log sub x over 25 times 8x cubed times 125x over 4. Further simplify, it will be log 8 times 125 over 25 sub x times x cubed times x. And it will be log 10 to the power of 9 over 2, where we can again apply the power law. It will become log 9 over 2 log 10, where the log 10 base and the body the same, it will equals to 1. And the final answer will be 9 over 2. Here is the solution for B. For B, the expression contains 3 log, which is ln. And we can see that the first 2 terms, there is a constant multiplied in front. Therefore, we need to use the power law so that the half will becomes ln 9e squared to the power of half. For the second term, the 2 will becomes ln e over 3 square. The third term, we just copy down. Now, when we reach this level, we can see that these 3 lns, we have minus and plus. We can apply law number 1 and law number 2. So the minus becomes divide, the plus becomes multiply. Hence, it will be ln 3e divided by e squared over 9 times e over 18, which will become ln 3e times 9 over e squared times e over 18. Further simplify, we get ln 3 over 2. So this is the final answer. Now here is the solution for C. From here we can see that these three terms contains the log. Hence we can apply law number 1 and law number 2. The plus becomes multiply, the minus becomes division. Hence it will be log x 16 times 32 divided by 2. We combine them together, it will be log x 16 times 32 over 2, and the answer will be log x 64. This is the final answer. Do you get all the answers correctly? Now, let's look at another example of simplifying logarithmic expressions. Simplify and express as a single logarithm. For log 3, 1 over 125 plus 3, log 3 15 minus 2. Here is the solution. From the given expression, we can see that there are three terms. The first two terms contain log and the last term is a constant. For the second term, there is a constant 3 multiplied with the log. Therefore, we'll use the law number 3 or the power law to bring up the 3, which becomes log 3 15 cubed. The first and the third term we will just copy down. Now at this level we can see that the first two terms contains log, but the last term there is no log. Therefore we can apply the law number 1 to change the plus becomes multiply, which is log 3 1 over 125 times 15 cubed, then minus 2. So we can simplify the constants in the bracket and it is 27. So log 327 is 9, and for this expression it becomes 9 minus 2. The answer is 7. Let's try this similar example yourself. Evaluate the following without using calculator. A. Log 3 324 minus log 34 plus log 31. B. Log 125 plus log 8 plus log base 4 64. You can pause the video and try to do it yourself. Here is the solution. For A, log 3 324 minus log 34 plus log 31, we can see that all these three terms contains the log with the same base 3. Therefore, we can apply law number 1 and law number 2. For minus, it becomes division. For plus, it becomes multiplication. Then it will be log 3 324 times 1 over 4. And it will be log 3 81. Now, what's the value of log 3 81? So we can interpret it as 3 to the power of a number equals to 81. What is this number? So it is 3 to the power of 4 equals 81. Hence, log 381 equals 4. For B, log 125 plus log 8 plus log 4 64. We can see that the first two terms has log with the same base, but the third term, the log base is 4. So for the first two terms, we can apply law number 1, which we change the plus becomes multiplication. But for the third term, log 4 64, it is 3 because we know that 4 to the power of 3 equals to 64. Then we can simplify, it becomes log 1000 plus 3. So log 1000 is 3 because we know that 10 to the power of 3 equals to 1000. Therefore, it will be 3 plus 3 and the answer is 6. Do you get the answer correctly? The laws of logarithms can be used to solve equations. Here is an example. Solve the following equations. A. Log A 32x minus log A bracket 2x squared plus x minus 54 equals 3 log A 2. B. Log bracket 6x plus 4 minus log bracket x minus 6 equals 1. Here is the solution. For A, let's look at this equation. We can see that from the left hand side, we have two logs with the same base A. For the right hand side, the log has a constant 3 multiplied with the log. Therefore, we can apply quotient law and power law. From the left hand side, the minus becomes division. It becomes log A 32x over 2x squared plus x minus 54. And the right hand side, the 3 becomes the power, which becomes log A 2 cubed. Since both sides have the same log, we can compare the bodies, which means 32x over 2x squared plus x minus 54 equals 8. We can solve this equation, which will become 32x equals 8 bracket 2x squared plus x minus 54. 32x equals 16x squared plus 8x minus 432. Bring over the 32x to the right hand side, which becomes 0 equals 16x squared minus 24x minus 432. Divide by 8, we get 0 equals 2x squared minus 3x minus 54. Factorize, which becomes 0 equals x minus 6, 2x plus 9. Hence, x equals to 6 or x equals to negative 9 over 2. But we need to check the answer. If x is negative 9 over 2, when you substitute inside the equation, we can find that for the first term, log A 32x, it will become a negative body, which there is no solution. Therefore, we need to reject x equals negative 9 over 2. Here is solution for B. Now, look at this equation. The left hand side, we have two logs with the same base, and in between is a minus. The right hand side is a constant 1. We can apply the quotient law. With the minus becomes division. Therefore, it will be log 6x plus 4 over x minus 6 equals 1. Now we can apply the anti-log law, which will be 6x plus 4 over x minus 6 equals 10 to the power 1. Now we can solve as normal algebra, which is 6x plus 4 equals 10 times x minus 6. Expand, we get 6x plus 4 equals 10x minus 60. 4x equals to negative 64 and x equals to negative 16. Here is a similar example that you can try yourself. Solve the following equations. A. 2 log 5x minus log 5x minus 4 equals to 2. B. Log bracket x squared plus 9 equals 2 log x plus 1. C. Log 5 50 plus 4 log 25p equals log 5 bracket 2p plus 4 plus 2. D. Log 2 square root of 5p plus 1 plus 2 log 9 3 equals log 4 p minus 2 plus log 4 64. You can pause the video and try to do it yourself. Here is the solution. For A, you can see that the first term, you have a constant 2 multiplied with log 5x. So you can bring up the 2 by applying the power law. It will be log 5x squared. Then minus log 5 bracket x minus 4 equal to 2. Then at this level, we can see that the first two terms, you have the log with the same base 5, we can use the quotient law. It becomes log 5 x squared over x minus 2 equals 4. Now, when we reach this step, you can see that the left hand side is a single log, the right hand side is a constant. We can apply the anti-log law, which becomes x squared over x minus 4 equals to 5 squared. And x squared equals to 25 bracket x minus 4. Expand, we get x squared equals 25 minus 100. We get x squared minus 25x plus 100 equal to 0. Factorize x minus 5, x minus 20 equal to 0. Hence, x equals to 5 or x equals to 20. For b, so log x squared plus 9 equals to log x plus 1. So from here, again, we can see that there's a constant 2 multiplied with the log x, right? We can bring this term to the left hand side first, then we can increase the constant, becomes log x squared. So the equation becomes log bracket x squared plus 9 minus log x squared equals to 1. And here we can apply the quotient law. The minus becomes division. And the log, we can use anti-log, which becomes x squared plus 9 over x squared equals 10 to the power 1. And it will be x squared plus 9 equals to 10x squared. So 9x squared equals to 9, x squared is equal to 1. Hence, x equals to 1 or x equals to negative 1. But we have to double check the answer. If x equals to negative 1, so the term on the right hand side, right, the log will be a negative body. So there's no solution for a negative body of log. Hence, we need to reject x equals to negative 1. Here is the solution for C. Log 5 50 plus 4 log 25p equals log 5 2p plus 4 plus 2. So we can, when we look at this equation, so the second term, the base is different. Then we need to change the base. So it becomes 4 log 5p over log 525. And the right hand side, the first term with a log, we can move to the left hand side, becomes minus log 5 2p plus 4. And left with a constant at the right hand side. So log 525 is 2. We can cancel with the 4. Becomes log 550 plus 2 log 5p minus log 5 2p plus 4 equal to 2. And we can apply product and the quotient rule. Or and increase the power first. The 2 becomes log 5p squared. So power quotient and the product law will be log 5 50p squared over 2p plus 4 equals to 2. Now the left hand side with a single log, the right hand side with a constant, we can apply the anti-log law, which will be 50p squared over 2p plus 4 equals 5 squared. And we get 50p squared equals 25 times 2p plus 4. 50p squared equals 50p plus 100. Hence 50p squared minus 50p minus 100 equals to 0. Divide everything with 50, we get p squared minus p minus 2 equals to 0. Factorize p plus 1, p minus 2 equals to 0. Hence p equals to 1 or p equals to 2. Again, we need to double check the answer. If p is a negative 1, we get a negative body for the log. So it doesn't make sense. Then we need to reject p equals negative 1. Here is the solution for D. Log 2 set 5p plus 1 plus 2 log 9 3 equals log 4 p minus 2 equals log 4 64. So the log 9 3 is half the log 4, 64 is 3. And the first term on the right hand side, we have different base. We want to change the base to 2. Therefore, it becomes log 2 p minus 2 over log 2 4. And so the next step, right, we can bring the terms with log to the left hand side, the terms with constants to the right hand side. It becomes log 2 set 5p plus 1 minus log 2 p minus 2 over 2 equals 3 minus 1. So we can bring out the constant, right? It will become log 2 square root of 5p plus 1 minus log 2 p minus 2 to the power of half equals to 2. So the power half is actually set. So we can apply the quotient law and it becomes log 2 set 5p plus 1 over set p minus 2 equals to 2. Now over here, the left hand side is a log, the right hand side is a constant. Apply the anti-log law and apply also the rule that we learned in surd. So if we times surd, 5p plus 1 over p minus 2 equals 2 square. Okay, we square both sides and we'll get 5p plus 1 over p minus 2 equals 4 square. So 5p plus 1 equals 16 bracket p minus 2. So 5p plus 1 equals 16p minus 32. Therefore, 11p equals 33, p equals to 3. You can double check p equals to 3, right? Substitute into the equation, everything makes sense. Therefore, p equals to 3. Now let's look at one example that involves solving logarithmic equations with the ln function. Solve the following equations. A, 3e to the power of y minus 5 equals 2e to the power of negative y. And B, e to the power of x minus e equals 10. So here's the solution. For this example, actually most of the time we are solving with applying the indices laws. So for A, 3 times e to the power of y minus 5 equals 2 times e to the power of negative y. So we can see that there is a negative power. Then we can change it to becomes 2 over e to the power of y. And then from here, everything times with e to the power of y, I will get 3 times e to the power of y square minus 5 times e to the power of y equals 2. So we can say let x goes to e to the power of y to make our equation simple. It becomes 3x squared minus 5x equals 2, or 3x squared minus 5x minus 2 equal to 0. Factorize x minus 2 times 3x plus 1 equal to 0. X equals to 2, or x equals to negative 1 over 3. So from here all the way to this step, we just solve the equation like we are solving the indices equation. Okay, now we substitute back x to e to the power of y equals to 2. So from here, right, we can apply the ln. So it becomes y equals to ln 2, which you can press calculator, the value will be 0.693, which has been rounded off to 3 significant figures. Or e to the power of y equals to negative 1 over 3, which there is no solution. Here is the solution for B. E to the power of x minus e equals to 10. We will ln both sides. And this is what we get. Ln e to the power of x minus e equals to ln 10. We can apply the power law. So it becomes x minus e times ln e equals to ln 10. And we know ln e is 1. Therefore, x minus e equals to ln 10. X will be ln 10 plus e. And we can press calculator. The value will be 5.02, which has been rounded off to 3 significant figures. Here is the similar example that you can try yourself. Solve the following equations. A, 2 times e to the power of y plus e to the power of negative y equals 3. B, 2 times e to the power of 2x plus 3 equals e to the power of y plus 3 plus 15 e cubed. You can pause the video and try to do it yourself. Here is the solution. For A, we can change the power of the negative y becomes 1 over e to the power of y. Then the next step, right, we can multiply everything with e to the power of y, which becomes 2 times e to the power of y squared plus 1 equals 3 times ey. Okay, then we bring the 3ey to the left hand side. It becomes 2 times ey squared minus 3ey plus 1 equal to 0. Now we can start to substitute. Let x go to e to the power of y to make our equation simple, which will be 2x squared minus 3x plus 1 equal to 0. So we can factorize. It becomes x minus 1 times 2x minus 1 equal to 0. My x equal to 1, or x equals to 1 over 2. Then substitute back e to the power of y equals to 1. Hence the y is 0. E to the power of y equals to half. So when I change it to ln, the the y will be equals to ln half. When I press the calculator, the answer will be equals negative 0.693, and the answer is rounding up to 3 significant figures. For B, 2e to y plus 3 equals e to the power y plus 3 plus 15e cubed. So we need to modify it, right? We see the plus for the power, we can change it to becomes multiply. So it will be 2e cubed times e to the power y square equals, right, the e cubed ey plus 15e cubed. Then we bring everything to the left-hand side. It will be 2e cubed ey square minus e cubed ey minus 15e cubed equal to 0. So you can factorize the e cubed and let x equals to ey. So it will be 2x squared minus x minus 15 equal to 0. Factorize x minus 3, 2x plus 5 equal to 0. Hence x equals to 3 or x equals to negative 5 over 2. So substitute back ey equals to 3. Hence y is ln 3 and it is 1.10. The answer has been rounded off to 3 significant figures. So ey equals to negative 5 over 2, which is no solution. Do you get the answer correctly? Here is another example involving solving logarithmic equations. Find the value of k for the equation log 2 5k plus 1 minus log 4 k minus 2 equals log 4 64 minus 2 log 93. Here is the solution. Let's look back to the equation. Log 2 5k plus 1 minus log 4 k minus 2 equals log 4 64 minus 2 log 93. So from here, we can see that there are constant log, which is this log 4 64 and 2 log 9 3. Therefore, we change them to constant terms, and it will becomes log 2 bracket 5k plus 1 half, because this is a third, then minus log 4 k minus 2 equals, so log 4 64 is 3, then this log 9 3 is half. Okay, so then minus 2 half. Therefore, we can simplify, and the next step is to change the base, because we look at here, this log is base 2 and this log the base is 4. So it becomes half log 2 5k plus 1. So we will change the base 4 to base 2. Usually we would want to lower down the value of the base. Hence it becomes log 2 k minus 2 over log 2 4, and then over here it is equal to 2. Then we'll get half log 2 5k plus 1 minus half log 2 k minus 2 equals to 2, because over here log 2 4 is 2. Then we can multiply 2 from both sides, left side and right side, and we get log 2 5k plus 1 minus log 2 k minus 2 equals to 4. Next, we apply the quotient law, because there is a minus here, right? So minus will become divide. Hence, it becomes log 2 5k plus 1 over k minus 2 equals to 4. Then apply anti-log law. We'll get 5k plus 1 over k minus 2 equals to 2 to the power 4. Then the rest is just solve it by algebra. We get 5k plus 1 equals 16k minus 32. 11k equals to 33, and k equals to 3. So here is one similar example that you can try yourself. Given that log 3 y minus 1 equals 2 log 3x plus k equals 10. When x equals to 27, find a, the value of k, and b, y in terms of x. You can pause the video and try to do it yourself. Okay, here is the solution. For a, given the equation 2 log 3 x plus k equals to 10. So when x equals to 27, we just substitute the value into the equation, which will become log 2 log 3 27 plus k equal to 10. So the log 3 27 is 3 because 3 cubed is 27, hence it will be 2 times 3 plus k equals 10. So k will be equals to 4. For b, right, look back to the equation, right, we can write it as log 3 y minus 1 equals 2 log 3 x plus 4. Or we can rewrite the equation, the 2 become the power square, which becomes log 3 y minus 1 minus log 3 x squared equal to 4. And apply the quotient law, it will be log 3 y minus 1 over x squared equals to 4. And anti-log law, it will be y minus 1 over x squared equals 3 to the power 4. Therefore, y minus 1 equals 81 x squared, or y equals to 81 x squared plus 1. So this is the equation where y is in terms of x. Do you get the answer correctly? Solving simultaneous equations involving logarithm. Here is the example. Solve the simultaneous equations. Set e to the power x equals e to the power 2y. Log 4 x plus 2 equals 1 plus log 2y. Here is the solution. So we name the first equation as the first equation, and then this is the second equation. Therefore, from the first equation, right, we can rewrite the equation. The third becomes to the power of half, and therefore it will be e times e to the power x over 2 equals e to the power 2y. So we can combine them together, become e to the power 1 plus x over 2 equals e to the power 2y. Therefore, we compare the power since both sides have the same body, which is e. Therefore, 1 plus x over 2 equals 2y. So both sides times with 2, I will get 2 plus x equals 4y. Hence, x equals to 4y minus 2. So this is the third equation. Then from the second equation, log 4 x plus 2 minus log 2y equals to 1. I just bring the log y to the log 2y to the left hand side here. Okay, then become log 4 x plus 2 minus log 2y equals to 1. Then we can change the base since both logs, right, they have different base. And again, we'll change the higher base to the lower base. Log 2 x plus 2 over log 2 4 minus log 2y equals to 1. Then the log 2 4 is 2. So then it will become half. And both sides times with 2, I will get log 2 x plus 2 minus 2 log 2y equals 2. Next, the 2 becomes square. It will be log 2 x plus 2 minus log 2y squared equals to 2. Then we can apply quotient law. It will be log 2 x plus 2 over y squared equals 2. Hence, now we apply the anti-log law. It should become x plus 2 over y squared equals 2 squared. Hence, x equals 4y squared minus 4 minus 2. And this is the fourth equation. We can equate the third and the fourth equation together. It will become 4y squared minus 2 equals 4y minus 2. So the third equation is here, x equals to 4y minus 2. And the fourth equation is here, y equals x equals to 4y squared minus 2. Right? They be only with the y. Now we can solve this equation, right? And we get y equals to 0 or y equals to 1. So if y equals to 0, then x equals to negative 2. If y equals to 1, then x equals to 2. So this is the solution for this simultaneous equation. Yeah, then we need to check, right? When x equals to negative 2, we will reject this answer because when we substitute inside the log here, it will get 0. So for the body of a log, it shouldn't be 0. Hence, x equals to -2. We should reject this answer. Therefore, x equals to 2 and y equals to 1. Now, here is a similar example that you can try yourself. Solve the simultaneous equation. E to the power of 3y equals e to the power of 6 x. Second equation, ln 3x plus 3y equals ln 2 plus ln 5. So you can pause the video and try to do it yourself. Here is the solution. So we name this is the first equation and this is the second equation. So from the first equation, 3 to the power of 3y equals e to the power of 6 plus x. So since both have the same body, we can combine them and become plus the power. Okay, then the next thing is since left hand side and right hand side has the same body, we can compare the power, which becomes 3y equals 6 plus x. Hence, x equals to 3y minus 6. Now, from equation number 2, ln 3x plus 3y, right? And the right hand side, it is a plus. We can get it becomes ln 2 times 5. And since both sides have the same ln, right? And we can compare the body, which will becomes 3x plus 3y equals 10. So we can name this as the third equation. So now I substitute the third equation into the last equation, which will becomes 3 times 3y minus 6 plus 3y equals to 10. Expand, simplify, we get 12y equals to 28 and y equals to 7 over 3. Therefore, x equals 3 times 7 over 3 minus 6, which is we get from the third equation here. Therefore, x equals to 1. Application of logarithm. The example. A scientist is studying a colony of ants, and the estimation of the number of ants in the colony can be calculated with the formula 25,000 times e to the power of 0.01 n, where n is the number of days from the first day of his study. A. Estimate the number of ants in the colony correct to the nearest 100 after 10 days. And B. After how many days the number of ants will be more than 100,000. Here is the solution. So from the question, right, we know that n equals to 10 because it says after 10 days. Therefore, the number of ants after 10 days will be, just substitute the value of n equals to 10 into the equation, which is 25,000 times e to the power of 0.01 times 10. And we get 27,600, which has been the answer has been rounded off to the nearest 100. For B, since they want more than 100,000, then the equation will be 25,000 e to the power of 0.01 n greater than 100,000. So bring over the 25,000 to the right hand side, it becomes divide. And e to the power of 0.01 n will be greater than 4. Now from here, we need to apply ln function here, which will becomes 0.01 n greater than ln 4. N will be greater than ln 4 divided by 0.01. Then we can press calculator. N is greater than 138.6. So, which means after 139 days, the number of ants will be more than 100,000. Here is a similar example that you can try yourself. William invests a certain amount of money in an investment fund so that its amount after t years is given by the equation A equals 50,000 times 1.5 to the power pt, where p is a constant. How much does William invest At the beginning, after 1 year, William expects his money will become $80,000. Now, calculate the expected amount after 21 months. See at least how long does William need to wait if the expected amount will be more than $1 million. So leave your answer to the nearest month. You can pause the video and try to do it yourself. Okay, here's the solution. A, right? So since we want to find how much he invests at the beginning, which means t equal to 0, we substitute the value into the equation, which becomes A equals 50,000 times 1.5 to the power of 0, and the answer is $50,000. So that means William invests $50,000 at the beginning. For B, so we can get t equals to 1 and A equals to 80,000. So substitute the value into the equation, which becomes 80,000 equals 50,000 times 1.5 to the power p. So 1.5 to the power p will be equals 1.6. Now from here, we can log both sides and we get p equals log 1.6 over log 1.5. And press calculator will get us 1.159. So that means A equals 50,000 times 1.5 to the power of 1.159t. So 21 months equals 1.75 years. Therefore, the t is 1.75, where the equation becomes A equals 50,000 times 1.5 to the power of 1.159 times 1.75. And this will give us the answer $113,809.88. So for C, okay, we can write the inequality here. The A must be greater than $1 million. Now substitute the formula or the equation inside, which is 50,000 times 1.5 to the power 1.159t greater than 1 million. So 1.5 to the power 1.159t is greater than 20. And now we use log, which we log both sides, and we get 1.159t greater than log 20 over log 1.5. Hence, t is greater than 6.375 years. So it means that William needs to wait at least 6 years and 5 months. So do you get all the answer correctly? Now, we want to learn how to sketch the graphs of exponential functions. Here is the general formula for the basic exponential function, y equals to a to the power of x. And the graph will look like this, where it cuts at y-axis at 1. So if the equation is y equals a to the power of negative x, then it is also can be written as y equals 1 over a to the power of x. And the graph will look like this. Actually, it is a reflection of the first graph along the y-axis, where it also cut the y-axis at 1. So next one, if y equals to negative a to the power of x, then this will be the graph. It is actually similar with the first graph, but it's a reflection along the x-axis, and it cuts the y-axis at negative 1. And how about y equals to negative a to the power of negative x? And or we can rewrite the equation becomes y equals to negative 1 over a to the power of x. And this is the graph. It's actually a reflection along the y-axis from the third graph. It also cuts at y-axis at negative 1. So what you need to do is you need to remember the shape of the graph for these exponential functions. you can take some time and remember the graph. So from all the graphs above, so we can see that y-intercept is 1 or -1. The x-axis is the asymptote. So asymptote means that the graph won't touch the x-axis. Right now, after you have remembered the graphs of basic exponential functions, let's look at one example here. Sketch the graphs of each of the following functions. A. Y equals e to the power of x plus 1 plus 2. And B. Y equals 3 e to the power of 1 minus 2x. So here's the solution. For A, we can start from the basic function y equals to e to the power of x, which will look like this. And it intercept the y-axis at 1. So the next one, right, the power is plus 1. So what does it mean plus 1? So that means when x goes to 0, then y is e to the power 1. So that means, right, this curve now cuts the y-axis at e. Now, next we move on. Y equals e to the power x plus 1 plus 2, which is the equation given by the question. So what does it mean? It means that we need to shift the whole graph 2 units to the top direction, 2 units up. So, or we can shift the x-axis 2 units down. So usually I would recommend you to shift the x-axis 2 units down, because you don't have to erase the whole graph and redraw, which will be very messy. So you just need to erase the x-axis and redraw the x-axis with one line. So now it will look like this, and the graph cuts at y-axis at e plus 2. Okay, so this is the final graph for this equation, y equals e to the power of x plus 1 plus 2. And yeah, one more thing is you see this dotted line. What is this dotted line means? So this is the asymptote. Remember, right? It means that the graph, it won't cut or it won't touch the asymptote. For this case, right, the asymptote is y equals to 2. Okay, now, so the solution for B, we'll start from y equals to e to the power of negative x. So the graph will look like this. Okay, and you cut the y-axis at 1. Now move on to negative 2x, right? E to the power of negative 2x. So what does it mean, right? It actually, the graph will look the same. The only difference, right, is that the graph should curve up more steeper. Okay, same shape, but the graph is steeper. Next one, we move on to y equals e to the power 1 minus 2x. So now what we need to do is, when x goes to 0, the y will be e. Hence, this point will be e. Next, y equals 3e to the power 1 minus x. So we need to multiply all the y values by 3. So in other words, this is the graph and it cuts the y-axis at 3e now. Okay, next let's move on to graphs of logarithmic functions. The basic equation is y equals to log ax, and this is the basic graph for this basic function, y equals log ax, and it cuts the x-axis at 1. If y equals to log a negative x, then the graph will look like this, and it cuts the x-axis at -1. If you look at it, it's actually a reflection of the first graph along the y-axis. Now, the next graph is y equals to negative log ax, and the graph will look like this, and it cuts the x-axis at 1. So this is a reflection of the first graph along the x-axis. Next, y equals to negative log a negative x. Okay, so if you think carefully, you can guess how the graph looks like, and the graph will look like this. Okay, it will cut the x-axis at -1. So you look at it, right? It's also a reflection of the third graph along the y-axis, which means that the negative x becomes positive x, the positive x becomes the negative x. So what you need to do is similar with the exponential function. You have to memorize these three basic logarithmic function, the graph, before you want to answer the question. So from all the graphs above, we can see that the x-intercept is either 1 or -1. And the y-axis is the asymptote. Alright, now let's look at an example here. Sketch the graph of each of the following function. A, y equals ln 4x minus 5. And b, y equals ln 3 minus 2x. So here's the solution. For A, we'll start from the equation y equals to ln x. So this is the basic graph which will look like this, and it has the x-axis at 1. So now the next step, right, we'll think about y equals ln 4x. When x go to y, when y go to 0, so the ln 4x will be 0, which means 4x equals to 1, x equals to 1 over 4. Therefore, this graph now will cut the x-axis at 1 over 4. Next, we move on, right, to y equals to ln 4x minus 5. So now for this case, when y equals to 0, the ln 4x minus 5 equal to 0, the 4x minus 5 is 1, hence x is 3 over 2. So to find the asymptote, so we need to let 4x minus 5 equal to 0, means x goes to 5 over 4. Now, this is the graph. It cuts at x-axis at 3 over 2, and the asymptote is x equals to 5 over 4. So this is the final graph for A. Now let's move on to B. We'll start from y equals to ln negative x. So this is the basic graph, and it cuts at x-axis at -1. Then we go to y equals to ln negative 2x. So from here, when y equals to 0, ln negative 2x equals to 0, means negative 2x equals to 1, x is negative half. So now the graph cuts the x-axis at negative half. Next, y equals to ln 3 minus 2x. So when y equals to 0, ln 3 minus 2x equals to 0. So 3 minus 2x is 1, and x equals to 1. To find the asymptote, let 3 minus 2x equal to 0, x equals to 3 over 2. So when x equals to 0, y is ln 3. Hence, this will be the graph where it cuts at x-axis at 1. This is the asymptote, x equals to 3 over 2, and the y-axis at ln 3. So this is the final graph for B. Finally, let's look at the graphical solutions involving exponential or logarithmic graphs. Here is an example. Sketch the graph of y equals ln x. And by drawing a suitable straight line on the same graph, find the number of solutions of the equation x squared e to the power x minus 2 equals 1. Here's the solution. So the first part, right, the graph of y equals to ln x should be easy if you memorize the shape of the graph, which will look like this, and cut the x-axis at 1. Now, for the second part, right, from the given equation, which is x squared e to the power x minus 2 equals 1, we need to ln both sides and then apply the product law here. Becomes ln x squared plus ln e to the power x minus 2 equals to ln 1. And we'll get 2 ln x plus x minus 2 ln e equal to 0. So if we do 2 ln x plus x minus 2 equal to 0, so ln x equals to half 2 minus x. So why we want to arrange the equation into this form? Because we know that the y is ln x, therefore, right, rearrange it becomes y equals to 1 minus half x. So we need to plot this graph, which is a straight line. So what we can do is, right, we let x equal to 0, then the y is 1. So from the graph, we plot the 1 here, and then let y equal to 0, the x is 2, so we can plot the graph here, the point here, and then we draw a straight line. We found that there is only one intersect point between the two graphs, therefore there is one solution. Alright, that's all for this video. Thanks for watching. Do you have any question to ask or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it to your friend. Alright, until then, see you in the next video. Have a great day ahead.